been a while. It's been a while. It's been like at least a month, month and a half. Lots of stuff has happened. Long story short, I was going down too many rabbit holes and I want to set a deadline for this little engine that I'm writing. I want to make a game in it. And so I need to finish up all the rendering that I'm doing. And so I was working on another port for WebGPU. I think I called it WebGPU test. New because last year I wrote an old one. But here, how many lines do we have so far? This is just the entire WebGPU renderer with a bunch of different pipelines. To verify it, I was having trouble debugging it, and I found a little article where I didn't implement it the same way, but the basic idea is that you can create a very tiny font atlas. Like, I just did 64 by 64. I only use half of this. Like, I use the numbers, and I use the ABC, like capital and lowercase glyphs. And if you look closely, I can't zoom in anymore, but they are 3 by 5 little glyphs. I have a set width and height for every single glyph, and then I just need to specify the X and Y position. And I'm getting ahead of myself. So it's 64 by 64. You could split each row of 64 bits into two 32-bit integers, and you could treat all the white pixels as a 0 and all the filled pixels as 1. So 0, 1, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 0, 1. You know, you can read this into a 32-bit integer, print it out as hexadecimal, and then you can use that as an array in a shader, and like a fragment shader, for example. And this is that entire font atlas in an array. And then you can sample that array with different positions, like every single pixel in the fragment shader, you reverse map it to that location in the array, and you can print out whatever you want. And so in this case, we are very laggy here. You can see I'm printing out hello. And I also, this is still the software renderer. We're blitting it to the graphics card now. And I can overlap it with another shader that I've been experimenting with, which is from Inigo Quiles. I'm not pronouncing that right, but he is a graphics programmer genius. And he has all these little algorithms for, it's very laggy. All these little algorithms right here for drawing all these different sign distance field shapes with a graphics card. And that's what I'm trying to do now. If you look over here, the only thing that I'm doing is, wow, okay, well, I don't have zooming in yet for the graphics card. You can see this little swirly thing. This is me failing to get a sign distance field on one of the physics objects. But we still have that. Oh yeah, I have way more buttons now. So this is the WebGPU test where I have we have the model matrix, the camera matrix, and the the perspective projection matrix on all these different objects, a little bit of lighting. I'm pushing all of my text rendering through to the graphics card now, a bunch of stuff happening. It's been a whole month and I've just been grinding away on these graphics because the eventual end goal, sorry, I'm in New York, it's very noisy, I hate New York, it is miserable, never come to New York. But I'm working on, I guess I can just pull it up, the natekilo.com website. You click this, it'll open up this page, and then you click on engine. So I can already host my WebAssembly engine. Of course, I'm not rendering any text yet, but I'm already porting the engine to WebAssembly, but it's still software rendered, and so I want to get it faster, and the way to get faster rendering in the browser is to use like WebGL or WebGPU, which is the newer one. And so right now I'm just testing out this native port of WebGPU to make it easier to port to the website later, so that I can port the whole engine there, and then I can host my own game in it, and then I can finally make my own game. And that is the end goal we're shooting for. It'll take a few more months, like another month to port this over, once I can actually start rendering all the shapes, the rest of the stuff, but you know, the text is being handled pretty well. Another thing I was working on was I wanted to, show the little artifacts for the website, and so I wrote a whole pipeline where now that I'm sending all of this data to the graphics card, I can get it back out and I can start recording stuff. Like I can click this little button up here, and I can just, I guess it'll record everything, won't it? Like, let me just test all this out. We'll stop recording it, and then we'll go to recordings. It just finished saving it, and so what's happening is that every single frame I get back from the graphics card and I pipe it to FFmpeg. I'm not writing my own encoder anymore. Yeah, cool. Okay, so it's very slow because the engine itself, it's very fast because the engine itself is rendering at like 30 frames per second, and we are encoding it to 60 frames per second. So it's double speed, what you see here. But this is just to make a little artifact pipeline. Just another thing I was working on, a bunch of stuff that I'm working on that, I don't know, I should start streaming more again. I've been attending Recurse Center in New York, and so I've just been very busy walking there, walking back, doing New York stuff. It's horrible here, never come here. But that's what I've been up to. I'm really thrilled about this, I made this video to demonstrate this little debuggy thing. Because now, in the Fragment shader, you need to do pixel debugging. I can probably give you a little example. Let me move this over to the side, please. Give me 1 second as I try and snap it. I wrote all the code. Yeah. Okay, there we go. Let's get this over. Oh my god. Okay. This is the test.wgsl shader. Okay. So, I don't know. Let's just this covers the entire screen. So let's just do color equals vec3f. Very laggy. 1. So I have a hot reloading shader here. It'll go bright white. It'll blind you. I can just comment that. I won't press anything else, and I have this directory scanner that checks the files. It checks all these files in the shader directory that I'm pointing it at, and if any of them have changed, it automatically reloads that shader. I showed you for my website, I'm using the same code. I'm just recycling all this code that I'm writing for these different projects. But yeah, I guess I was just going to show you the shader. Yeah, the little text thing. So this is printing out. You can see in the top left corner. I can increase the scale. Why not? I'll increase the scale for you. I'll set it to that's too large. 30. How big does it get? It takes a second because we're also buffering all these frames that we're sending back and forth from the graphics card to the CPU, and we need to synchronize that and so they can accumulate. So you can see here, I'm testing when the mouse is within the shape. The distance when it's within the shape is negative. It's a signed distance field. Inside the shape, the position is negative. Outside the shape, it is positive, and so I just clamp it to 0. Just as an example of in the Fragment shader, where you have no visibility and you can't clearly understand what any given value is. I have this little pipeline that I made, and I can set up a little repo, so you can just copy this code and do the same thing with it. But yeah, now we can just print out whatever value we want in the Fragment shader, and it is very laggy. I can set it back down. You can see the performance here is all red. It's very laggy because for every single pixel we're doing this. We're calculating the whole string. We're formatting it. Lots of stuff going on. Very laggy, but it's very useful because now we have full visibility into the pipeline. I can set it to any value. We are setting it to debug value right here. Where do I set that? I'm setting it to, I scrolled past it. I set it multiple times. Okay, min-max, so I don't know, just as a little example, I'll set it to 999 or some other value. Why not some other value? You can't set it to every single pixel, p.x, that'll vary, pixel position.x, that'll vary for every single pixel, and so it'll start getting, it'll get very artifacty. And again, it's synchronizing, it's catching up, so this every single pixel position, it's drawing where it is on the screen. So of course we're going to get gibberish. So instead, you need some consistent value across every single pixel. So I can give the mouse position relative to the screen. It's only this slow because I'm buffering all these frames back and forth because I want to have the ability to record. I also set up this pipeline where I can record the last 5 seconds. So it's very slow. But yeah, I just wanted to show off that you can get debugging visibility into the graphics card. You just need to write a little font atlas, encode it into a hexadecimal array, and then write some code to format whatever you want to print out. And there you have it. You can do stuff like this. So that's all I wanted to talk about. I can make a little repo for you to copy and use at your leisure. It works for WebGSL. You might need to port it to other things. But yeah, that's pretty much it. Thanks for watching, ladies and gentlemen. Bye bye.